Welcome to Lavanya's computer classes. In this video, I will explain what is algorithm and what are the characteristics of algorithm. This topic is there in design and analysis of algorithms for JNTUH CSE 3-2 syllabus. So that's why I'm explaining what is an algorithm. What is an algorithm means it is a step-by-step procedure to solve a problem, because we are using computer for solving a problem. For solving any problem, we need some steps. So if you are writing all the steps for solving a problem, for finding a solution, for any problem we need some solution. For finding any solution for a problem, we have to write some steps. All the steps, step-by-step procedure to solve a problem for finding the solution. But all are using in simple general English language, that is called as an algorithm. So what is an algorithm means? Algorithm is a step-by-step procedure to solve a problem, but all the statements are using only simple general English statements, that is called as an algorithm. So what are the characteristics of an algorithm? What is the meaning of characteristics? Means for writing algorithm we have to follow some rules. So those are called as characteristics. The algorithm must contain these elements. That elements are called as characteristics. So the characteristics are: first one is input, second one is output, finiteness, fourth one is feasibility, next one is unambiguous, and last one is independent. So these all are called as characteristics of an algorithm. If you are writing any algorithm, the algorithm must contain these elements. These are called as characteristics. Because why you are writing algorithm means algorithm is writing purpose is for solving a problem, for finding solution. But the solution, everything is in simple general English. So these are the characteristics. Now I will explain one to another. For any computer block diagram computer means computer contains, we need inputs, outputs. But how we are getting outputs means first we take some inputs, then we do some work. That work is called as processing. After processing the work, we get the output. So we need inputs and we need output also. On input means whatever the elements you have to give it. Using the inputs, what we are getting, the final output, the final answer, that is called as output. So if you want to write any algorithm for finding any problem, we need either 0 inputs or more inputs. So for writing an algorithm, how many inputs we require means either 0 or more, depending upon the problem. Second one is output. Why we are writing the algorithm? We are writing the algorithm for solving solution, for finding solution of a problem. That means we need at least one output. If you are not get the output means you are missing something. So without output you are writing the algorithm, this is not a correct algorithm. You are missing some logic. So for outputs, how many outputs we require means minimum one output or many number of outputs. Because after writing so many steps, then also we are not get any solution, we are not get any output means it is not a correct algorithm. So that's why how many outputs we require means minimum one output or many number of outputs. So that is the second characteristics. Third one is, so minimum number of inputs are 0, minimum number of outputs are 1. Maximum is depends upon the program. Finiteness. So what is the meaning of finiteness means every algorithm must terminate after a finite number of steps. Because in the definition I said it is a step-by-step procedure. So how many steps? How many steps means 10, 12, 15 or 100, any number of steps. But only thing is you have to terminate at one point. So if you are writing an algorithm, the algorithm must terminate after reaching some number of steps. So that is why it is called as finiteness. If it is going to infinity, it is not stopped, it is still going on, means somewhere you are doing some mistake. So that is called as finiteness. The algorithm must be terminated after a finite number of steps. Next one is feasibility. What is the meaning of feasibility? Means if we are writing any algorithm, we need some inputs also. So whatever the resources we are used, all resources should be available resources only. Feasibility means it should be feasible with only available resources. We are solving any problem. For solving the problem, we need some inputs, but all inputs must be available resources. Those are with the programmer only. So whatever the resources we have, using that resources and solving the problem, that is called as a feasibility algorithm. You don't have any value, but for finding that algorithm you have that value, means it is not feasible because that value is not available with you. So whatever the values we have, using those values and finding the solution, that is called as feasibility. Next step is unambiguous. What is unambiguous? Means we are writing so many steps, step by step procedure. All steps must be clear without any confusion. All steps must be clear and it must lead to only one meaning only. It not give any different meanings. Whatever the user is check that algorithm, means it should be clear and gives only one meaning only. There is no confusion for the programmers. That type of algorithms are known as unambiguous. For example, I am writing one line like this: is equal to a plus b. If you are seeing this line, you can easily, everyone can understand a is one number, b is another number. Both are, what is the answer? What is this algorithm? Is sum of two numbers. So like this, if you are understanding every line clear, that is called as unambiguous algorithm. Next one is independent. What is the independent? Means the algorithm have step-by-step directions which should be independent of any programming code. That means the algorithm is not at all belongs to any particular programming language. The algorithm is not belongs to C language, or the algorithm is not belongs to any other like Java or C++. It should be in general English. For example, just check it. Person A is there, person B is there. Programmer A knows only C language, programmer B knows only Java language. That means any person, Java program means that is not understood by A. If the program is in C language, means the program is understood by only person A. Java program is understood by B, C language is understood by the A. But if you are writing the solution for these problems in algorithm, what is algorithm? Algorithm means step-by-step procedure to solve a problem, but only thing is it is in general English language. If you are writing the general English language in algorithm, person A, person B, any other person can easily understand what is that problem, what is that solution. That's why algorithm is an independent of any programming language. That's why in this we don't write any syntaxes of any other languages. If you write the syntax of C, that person only C knows, who knows C language, that person can understand. If you are writing Python syntaxes, only Python programmers can understand. So it is not like that. So it is the algorithm for characteristics of algorithm. What is time and space complexity of an algorithm? So what is the meaning of time and space complexity? First I will go for time complexity. So what is time complexity? Time complexity means what is time complex? Time complexity means for running any algorithm, time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. That means you know what is an algorithm. What is an algorithm? Algorithm means it is a step-by-step procedure to solve a problem. So it is a step-by-step procedure to solve a problem. So how much time it required for executing these steps, that is called as time complexity. For running an algorithm, for executing any program, how much time is required for executing? That is called as time complexity. Now I will explain time complexity with some examples. So you know already algorithm means step-by-step procedure. Time complexity means how much time it required. For example, I will take one simple example like T of n equal to 2n square plus 3n plus 1. For executing this line, how much time we require, time complexity of this one. So for finding this time complexity of this line, first removing all drop lower order elements, lower order terms. So what is the lower order term? That is 3n plus 1. So just removing 3n plus 1. After the second one is drop all the constant multipliers. Second one is drop all the constant multipliers. So in this, which one is the constant multiplier? That is 2. 2n square, in this constant is 2. So removing that one also. So which term is left after removing the two cases means only n square is there. So for executing this line, what are the time, how much time complexity we need, means that is big O of n square. So that is the time complexity of this line, big O of n square. Next I will explain what is the time complexity for simple loop. Time complexity of a simple loop. For example, for I equal to 1, I less than or equals to n, I plus plus for loop. In this I want to execute only one line, that is x equal to y plus z, then close that loop. So how much time is required for executing this line for finding? That is called as time complexity. So inside the loop only one line is there. That line is executed constant number of times. So that line is taking as constant means C, means for executing that lines we need C. And loop, we go for loop. This loop, how many times the loop is repeated? That is depending upon the n. So what is the n? That number of times the loop is repeated. So how much time is required for executing this line means that is called as n times. So for executing the entire statement in this example, how much time we require means for loop n times, for constant C. So C into n. So what is the time complexity of this mean? That is called as big O of n. So that is the time complexity of any simple loop. Constant time and for loop n times. So big O of n is the time complexity for any executing simple loop. Now we will explain nested loop time complexity. If the program contains any nested loop, what is the time complexity? How much time is taking for executing the nested loop? Nested loop means one loop contains another loop. So first I will take first loop for I equal to 1. I less than or equals to n, I plus plus. This is the outer loop. Inside I will write one more loop, that is for j equal to 1, j less than or equals to n, j plus plus. This is the inner loop. Then I will execute one line, that is x equal to y plus z. So for this, how much time is required for executing these lines? Now I will tell you. So this is called as inner loop, j is called as inner loop, I is called as outer loop. That's why it is called as nested loop. Nested loop means one loop contains another loop. So for x is equal to y plus z, how much time is executing this line means constant time. For inner loop, how many times the inner loop is executed means that is also depending upon the n times. How many times the outer loop is executed means that is also depending upon n. So that is also n times in this example. Okay, so totally how much time we require means C into constant. For inner loop n, into outer loop n. C into n into n. N into n is n square. So C into n square. So how much time complex we require? That is big O of n square. For executing nested loop, we need O of n square. That is the time complexity of nested loop. Now I'll explain. Space complexity. So what is the space complexity? Space complexity of an algorithm means time complexity of an algorithm is the total amount of space or memory required by an algorithm for completion of its execution. It's called as space complexity. How much memory we require? So I will explain with one simple example. Void main int a, b, c, z, 4 variables, z equal to a plus b plus c, return z. Close the program. So how much memory we require for this simple example program? That is called as space complexity. So how many variables are there in this example? 4 variables. A, b, c, z. All are integer variables. So some processor for integer occupies 2 bytes and some are integer occupies 4 bytes. For example, I will take in this example integer occupies 2 bytes. So 4 variables are there. All 4 variables are integer variables. So 2 bytes of memory is required. So 4 into 2, 8 bytes of memory is required. 8 bytes of space we require for this example. For example, integer occupies 4 bytes means how much memory we require? 4 into 4. 16 bytes of space we require for storing these variables. So this is called as space complexity. How much memory we need it. Now we'll explain with one more example. For time complexity, space complexity. Now I am using some simple loop statements. For simple loop statements, how much space we need? For I equal to 1, void main int n comma I comma sum equal to 0, 3 variables. Scan of %d ampersand n. This program is in C language. Into a of 1 array declaration. For I equal to 0, I less than n, I plus plus. Simple loop. Then I will read array elements. Scan of %d ampersand a of I. Then sum equal to sum plus a of I. That means sum of all the elements in the array. This is the program for sum of all the elements in the array. After loop is completed, just I want to print the values, printf sum. So this is the program. For this program, how much space we require. Now finding how much space we require. So how many variables are there in this example? 3 variables, n, I, sum. So 3 variables, all are integer data type. So if it is occupies 4 bytes means how much memory we require? 3 into 4, 12 bytes of memory is required for the 3 variables. After that, here we are using simple loop statement. The loop is repeated, executedly repeated n times depending upon the n times. So we need how much memory we require means n loops of memory we require. All n are belongs to 4 bytes of memory is occupied means 4 into n, 4 n bytes of memory is required for storing these loop elements. So for storing these loop elements we need 4 n bytes. For storing these normal or ordinary variables we need 12 bytes. So how much total space required means 4n plus 12 bytes of memory we require. N is depending upon the values. So this much space or memory we required for executing this program. So that is called as space complexity. So this is the concept of time complexity and space complexity for an algorithm. I will go to explain step count method for calculating time complexity. In the previous video already explained what is time complexity. What is time complexity means how much time, the average time is taking for executing a algorithm. For executing one algorithm, how much time we require. That is explained by the concept of time complexity. Now in this video, how to calculate time complexity using step count method. So I will explain step count method in this example. For example, I want to calculate sum of elements, sum of all the elements in the given array. This is the program, sum of all the elements in the given array. For this program, in the given array, first I will write the algorithm for this program and then find what is the time complexity of this program. So first I will write the algorithm for this. So int sum is my program function name, and this is the sum of the elements in the given array. So I need one array, that is A, array name is A, and size of the array is n. So int A and int n. So this is the sum of the elements function name. Then flower brackets are started. Then sum, I want to calculate sum. So I will take one more simple variable, sum equal to 0. This is also integer data type. Next I want to take the loop because I want to calculate all the elements in the given array. So for I equal to 0, I less than n, I plus plus, then calculate sum. Sum is equals to sum plus a of I. So this is the function. Sum is calculated. Then we go for printing the sum. So return sum. So whenever the function is over, just close the algorithm. So this is the program algorithm for sum of all the elements in the given array. Now I want to find out what is the time complexity of this algorithm using step count method. So in this step count method, we have to prepare some table like this. One is the cost, then frequency, and then total cost. Cost, frequency, total cost. So what is the cost means? Cost is the number of times the particular line is executed. Frequency is the total number of times the particular line is executed. Total cost is the product of cost and frequency. Okay, so in this example, first to find out how many lines are there. How many lines are there means this is the step 1. First one is the heading, name of the cursor, name of the function, algorithm. This is not counted. The count is start from here. This is the count, first step, step 1. This is step 2. This is step 3, 4, and then this is the output step 5, and this is the step 6. Because it is the only 1 to 6 flower brackets, open brackets to last close bracket, the program is executed. So 6 steps are there. In these 6 steps, these brackets, for executing these brackets, the machine is not at all taking any time. So this is not considered. Line 1 and line 6 is not taking any cost of the time for execution. So we start from here. So this is the int sum equal to 0. So this is the initialization statement. So how many times this line is executed? What is the cost of this line? Means it takes only 1 because it is executed only once. That is called as frequency. So how much time is taking means you don't know. That's why we take some constant time. That is C1. So what is the total cost of that line? Means product of cost and frequency, that is 1 into C1, that is called as C1 only. So that is this line is completed. Then loop, for I equal to 0, I less than n, I plus plus. So how many times, what is the cost of this line? That is also we don't know. No? That's why take C2, constant time. Then frequency, how many times this loop will be executed. So how many times this loop will be executed means it is executed up to 0 to n minus 1. 0 to n minus 1 means how many times? N times. And finally checking n plus 1 also, because if the condition is false, then only it is exit from the loop. So for n plus 1 also it is checking. So that's why what is the frequency of the loop statement means that is n plus 1. N times the program is executed. For plus 1 is for checking the condition for exit also. That's why totally n plus 1. So what is the total cost means? C2 into product. N plus 1. This is for loop. Now next line. Sum equal to sum plus A of I. So how many times? What is the cost of this line means? This is constant C3. How many times the program is executed means it executed for n times. Whenever the condition is true, that time only the program is executed. So frequency is C3 into n. Now the last line is return sum. So what is the cost of this one means C4. How many times it is executed means only once. So total cost is C4 into 1 C4. Now I find the total cost of this total algorithm. So total cost equal to sum of all these costs. That is total cost of this algorithm equal to C1 plus C2 into n plus 1 plus C3n plus C4. Okay. Now I multiply C2 with n plus 1. So C1 plus C2 into n plus C2 plus C3n plus C4. So in these terms n is the common. So I will take n is common. So C1 plus n. N is there in the C2 plus C3 also. Plus C2 plus C4. So all constants are keep it in one place. So that is n into C2 plus C3 plus C1 plus C2 plus C4. So all constants are considered as totally constants only. So just keep it aside. So what is the time complex of this total entire algorithm is big O of n. So this is the time complexity for any algorithm using step count method. So this algorithm name is sum. So T of sum, T for time complexity of sum of n. N is the number of elements in the array. So O of n, big O of explain divide and conquer method. In the previous videos I already explained analysis of algorithms. What is an algorithm? How to write an algorithm and how to analyzing an algorithm. Now I go for divide and conquer method. So for any problem, first we are writing the algorithm for solution of a problem. For solving a problem, we are writing algorithm. So in the divide and conquer method, what is this means? It is a strategy. So what is this means? It is a strategy for solving a problem. It is a strategy for solving a problem. We have so many strategies are there. In these strategies, one method is divide and conquer method. So what is the strategy? What is the meaning of strategy? Means either it is an approach. How to solve a problem? What is the method? What type of approach you are taking? What the steps you are taking for solving a problem? That is known as strategy or design. How can you, what are the methods, measurements you are taking? What are the designing steps you are taking for solving a problem? That is known as a strategy. Either we select some approaches or designing how to solve a problem. So in this, so many methods are there. What are the different types of methods? So many strategies were applied for solving a problem. Those are, some are divide and conquer method, some are greedy method, some are dynamic programming method. Like this, so many methods are there, so many strategies are there. We can select any one of the strategy for solving a problem. The ultimate goal for in computer science is how to solve a problem. For that we apply, we are going some methods, approaching some methods or designing some methods. Those are known as strategy. Now in this example, you go for divide and conquer method, explanation of divide and conquer method. In the name only it is there. What is divide? Divide means it is divided into subparts. Conquering means win, solution. If you are solving the problem, ultimately we are getting the answer, that means you are conquering, that problem is solved, that is known as conquer. But how can you get the conquer? So if you want to conquer any problem, the problem will be divided into sub problems. For example, any problem with size is n, that means it is a very big problem. The big problem P, the big problem will be divided into sub problems P1, P2, P3, like this. We can divide it into number of sub problems like Pn. One big problem, larger problem will be divided into sub parts. So these sub parts is known as divide. First I have to divide the big problem into smaller problems. After smaller problems, now you find out solutions, because if the problem is small, small means automatically solution is, it is very easy. Solution is very easy. If the problem is big, then it is divided into next one. So solve solution 1, solution 2, solution of third problem, like this we can solve into nth problem. After solving all the problems, then we started combining all the solutions, then we get the solution of original problem. So like this we can solve any big problem. So if you are solving any problem, that is known as divide and conquer method. Any big problem, at a time if you want to solve that problem, it is very difficult. That's why the problem will be divided into smaller problems. Small problems or solving is easy. Big problem solution is very difficult. So divided. For example, after dividing sub problem like this, if size is also more, means again we apply it. Again we apply divide and conquer method. That's why divide and conquer method is known as recursive process. Because after dividing, again we feel it is size is again more, again divided and again sub problem like this. So this is the method of divide and conquer method. For example, in our real life, in our college, we are conducting some workshop seminar you want to conduct in the college. So it is a big problem. Conduction of workshop with number of students is very big problem, because it is divided into preparing. We have to prepare? Preparing invitation card, preparing posters, invitation of guest, booking the hall, seminar hall, you have to check it, hall is ready or not, seating capacity sufficient or not, mic is available or not. Like this, one big project will be divided into small projects, small works, and each and every work is checked by the one person. Algorithm DA and C means divide and conquer for the problem P. If the problem is small, then no problem, just written it, solve a solution of P. S of P means solution of a problem. If the problem is not small, if the problem is large size, then what you have to do? You have to do it, divided the program with large size into smaller instances like P1, P2, P3, so on, Pk, size Pk. One big problem will be divided into smaller problems up to Pk. Then apply D and C, divide and conquer, to each of these subprograms, like divide and conquer of P1, divide and conquer of P2, divide and conquer of so on up to Pk. If after dividing the solution problem into subproblem, still it is more size, bigger size, then I can apply it. Then return combining, divide and conquer of P1 and the solution of P1, solution of P2, solution of P2, Pk, like that we can solve it. After that, if it is a small p, again P means it is a problem. Smaller of P means Boolean value of function, either it may be yes or no. So like this we can solve the divide and conquer method. It is also known as recurrence. Why it is recurrence? Means after dividing the problem, again the problem subprogram is also bigger in the size. Then again we apply divide and conquer method. That's what is known as recurrence. In this we have so many applications are there. Those are the binary search applications and quick sort method, merge sort method and Strasson's matrix multiplication. In remaining videos, next videos I will explain each and everything: binary search, quick sort, merge sort and Strasson's matrix multiplication. So like this. Thank you for watching my video. If you like this video, please subscribe my channel, share it to your friends. Thank you. In the next video, so I will explain the applications of divide and conquer method. Thank you. In this video, I will explain binary search. Binary search with an example. Already in the previous videos, I will explain divide and conquer method. So binary search is also an example for one application of divide and conquer method. So first we go for what is binary search. Binary search is a fast searching algorithm with time complexity of O of L log n. So binary search is we have two types of binary search algorithms are there. One is linear search and the second one is binary search. The linear search is also known as sequential search. So linear search is also a good example for searching technique. But in this, if the search element is in the last element, if the which element you want to search, that element is in the last position, then number of iterations are more, number of steps are more. Finding that element, for finding one element, you have to check all the elements. If the size is more, it takes number of iterations. So that is the one disadvantage of linear search. For overcoming the disadvantage, we go for binary search. What is the binary? Binary means 2. Here all the numbers, the list of elements will be divided into 2 parts. Either we search the elements either in this side or like this, in this part. So that's why number of iterations are almost all, half of it will be reduced. That's why binary search is well suited method for searching an algorithm. So it is a fast searching algorithm. Because why it is fast means because either we can search either left hand side or right hand side depend upon the elements. And it is based on divide and conquer method. Binary search algorithm is a good example for divide and conquer strategy. And here we have to remember one point, that is all data items should be in the order. If you want to search any elements using binary search technique, all the items should be in the order. It is very, very important. So these are the some points in binary search algorithm. Now I will explain the algorithm of binary search algorithm. So algorithm BST, binary search BS, while low less than or equal to high. Here we need low element and also high element. I will explain with example. If the low element is always smaller than or equal to high, then calculate mid. How to calculate mid? Means mid equal to low plus high by 2. After calculating mid, then we need search element. We need mid element and search element. First we calculate mid element, that is low plus high by 2. Then search element. Then compare mid element and search element. If both are same, 3 points we require. First point is middle element and search element both are same. That means then we get it is a successful search and the element is found at middle of the position. Then stop your procedure. If it is middle element is greater than search element, that means search element is small compared to middle element, then go to left hand side. That means middle element is here, this is the middle element. Middle element is more means remaining all elements are smaller. So go to right hand side. Our third point is if the middle element is more than search element, then go to, that means middle element is small, search element is more, then go to right hand side. So like this we can check it. Either middle element equal to search element or middle element is greater than search element. That means middle element is more, go to left hand side. If the middle element is small, then go to right hand side. So like this we can start your procedure. Through example I will explain. Here I will take some elements. These are the set of elements. And once again I will tell you, in the binary search all elements should be in the order. So here I will take the elements 3, 7, 9, 10, 12, all are in the ascending order. and then 25, 29 like this. So first you will take the array form. So first find the positions also. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements are there. So these are my 15 elements. So in this first, which element is there? That is known as low, and which element is here? That is called as high. So what is the position of here? Low equal to 1, high equal to, what is our high value? 15. So here low less than or equal to high condition, we have to check it. 1 less than or equal to 15. Yes, condition is true. Once the condition is true, we have to do, what we have to do? We calculate mid element. How can you calculate mid element? Mid element equal to low plus high by 2. So what is our low element? 1. What is our high element? 15. 1 plus 15 by 2. That is 16 by 2. That is called 8. So what is our middle element? Middle element is 8. Okay. Now we go for search element. Which search element is also known as key element. Which element you want to find? That is, for example, we think it is 42. Key element is 42. So search element is 42. What is our middle element? 8th position. So here check it. What is your mid element? A of 8. The 8th position, which element is there? 29. What is your search element? Search element is 42. So first point, either mid equal to search. Is it clear? Is it true? 29 is equals to 42? Wrong. So then compare. Which one is higher? Mid element or search element? So what is our middle element? Middle element is 29. Search element is 42. So 42 is more than your middle element is smaller and search element is more. So search element is more, means then go to right hand side. That means here middle element na, so from here we go to right hand side. That means not necessary to check it in the left hand side. That is called as divide and conquer. Depends upon the middle element. Now it is divided into two parts, left hand side and right hand side. So in the right hand side, what is the elements are there now? Again 31, 36, 42, 47, 53, 55, then 62. So this is the elements. Now check the algorithm. If search element is greater than middle element, yes, search element is more than middle element, then what we have to do? Low equal to mid plus 1. So what is our low value actually? Low value is 1. Here starting low value is 1, high value is 15. Now whenever we coming to here, low value is middle plus 1. What is our middle? Middle element is 8. So low value is now 9. 9 element is here. So this is now considered as low. This is 9th position. 9, 10, 11, 12, 13, 14, 15. Okay. Now it is low and high is nothing. No change here. So high is still 15 only. Low is 9 and high equal to 15. Again calculate mid. How to calculate mid again? Mid equal to low plus high by 2. What is our low value? 9 plus 15 by 2. 9 plus 15, how much? 15 plus 9. This is 24 by 2. 9 plus 15, 24 by 2. What is 2? That is 12. Okay. So what is our middle element? 12th position. 12th position means mid element is now 47. But which element you want to search? Search element is 42. Again same thing. Mid equal to search? No. Again compare. Middle element is 47 and then search element is 42. So which one is more? Middle element is more. If the middle element is more, then the elements is in the left hand side from here only. That means again it is divided into two parts. Here either right hand side or left hand side. So which side have to go means check it, depends upon the value. The search element is smaller than middle element, go to left hand side. That means again we apply divide and conquer method. So in this what is the parts again? 31, 36, 42, enough. So what is the values of here again? It is in the 9th position, 10th position, 11th position. So whenever middle element is more than search element, then we go to high value, have to change it. High equal to mid minus 1. So what is high value? Low is nothing, no change. Low is 9 only. High value mid minus 1. So what is our middle value? 12. 12 minus 1 means it coming to here 11. So here L is equal to 9 only. Mid is now change it to 11. Okay, Nana? Again we have to do same procedure. Apply divide and conquer method again. Again we calculate mid. Low plus high means 9 plus 11 by 2. 9 plus 11 by 2 means 20. 20 by 2, that is 10. So what is our 10th? Middle element is 10. Middle element means this one. So middle element is 36. Search element is 42. Both are not same. So again do it. Searching. That means middle element 36 is less than 42. That means middle element is small and search element is more. That means you go to right hand side. Right hand side means here only one element is there. Whenever here search element is smaller than middle element. Middle element is smaller than search element. So whenever smaller than middle element is smaller than search element, go to right hand side, but check it. L value is changed to middle plus 1. So what is your middle plus 1? Middle value is 10. 10 plus 1, 11. Height we are not changed anything. So here only. Here only one thing. Left is here and low value is here. High value both are same. So again calculate mid. Mid is equals to 11 plus 11 by 2. That is 22 by 2. That is 11. So what is your middle element? The middle element is 11. So middle element is 11 means what is the 11th position? That is 42. Middle element is 42. What is your search element? Your search element is also 42. So mid equal to search. So 42 equal to 42. Then you are getting the element successfully in the 11th position. It is known as successful search. Binary search. See here, out of 15 iterations, 15 values are there. But 1, 2, 3, 4, within 4 searching, 4 iterations only we get that successful search. This is the main advantage of binary search. Binary means of. Given elements into 2 parts. Depends upon the middle value. Either we go for left hand side or right hand side. So this is like this. We can do the binary search algorithm. What is the complexity of binary search algorithm? That is O of log n. How can you calculate? I will explain in the next video. Thank you for watching my video. If you like this video, please subscribe my channel. Share it to your friends. Thank you.